Hello, 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 ladies and gentlemen. Today, I am going to be recording a video talking about simplified stoichiometry or conversion webs. Okay, now to do that, you need to actually know the conversion web, which is what this is behind me here. So the purple arrows are pointing at the three things that you might be asked to find in a conversion problem. The blue are the two things that you have to use in order to find them, and then the green is just the units for each of those five. So I'm going to step off screen so that you can pause this without me being in the way so that you can sketch this down. Now, I know this is a little blurry and somewhat hard to read, so the worksheet where we actually go over this has a probably clearer picture than this does, and obviously this is posted on the wall in class. So I'm going to get out of the way. I suggest you pause this for a second or two so that you can get this sketch down without me being in the way. So I'm going to step out for a sec. All right, that should be enough time. So now I'm going to actually change this view so that you can see the notes that we're actually going to be taking. So I'll let you get that down as well. So I would pause it here for just a second. All right. So I'm going to go through and I'm going to fill this in so that you can actually see what's going on. I am going to have to zoom out for the last one. This little dash here goes the entire way across the page, so that part might be a little harder to read. But again, all of this is on the first worksheet so that you can see it there. Now, items, the first one up top. Items is the number of particles that we are working with in whatever given problem we happen to be talking about. So items refers to particles, and in the context of a chemistry question, that's either going to be atoms, if we're talking about an element by itself, not a molecule, but just one atom by itself, okay, or a molecule, if we're talking about a compound or a diatomic or something else like that. Okay, the next one, I'm going to look a little bit here. There we go. N stands for the number of moles. Okay, and moles also has units of moles. Okay, now sometimes you might see this spelled with an E between the L and the S. This is true for both the value and for the unit. They'll both sometimes have an E in there because that is the old way it was spelled. So be aware, probably going to see both. Okay, and then we have our, oh, come on, get it there. There we go. Nope. I messed that up. I think I messed that up. Yep. Then we have our mass. Okay, and the mass has units of grams. Okay, now this is mass as in how many grams of something you've got, like how much matter are you made of, that old physical science term. Be aware, it does matter on capitalization here. So this N is lowercase. This N is lowercase. This M is also lowercase. It matters. We're going to introduce a capital M later on that means something else. So you don't want to get those two backwards. So save yourself some hurt later. This is a lowercase m that we're using for mass. That brings us to our molar mass. Molar mass is something that we spent some time actually calculating before we went on Christmas break. In fact, it was one of the first things we did when we came back from Thanksgiving break this year. Now, if you're watching this in the future, who knows? That might be completely wrong. But the molar mass is what MM abbreviates for. Okay, and that is, we say, the gram equivalency for 1 mole. Or, in more common terms, that's going to be how many moles, no, how many grams, sorry, how many grams does it take to equal 1 mole? So, for example, the molar mass for iron is 55.845 grams per mole. That means that in order to have 1 mole of iron metal, you have to have 55.9, I lost it, 55.845 grams of iron. If you have that much iron, you have 1 mole of iron. Yes, I know you don't know what a mole is yet. We're getting to that part. And that's the last one, Avogadro's number. So Avogadro's number is a value that we are going to use quite a bit. This is Avogadro's number. Now, you might not recognize the E if you're not used to seeing it written like that, but this number is in scientific notation. This is the normal way. You might be more used to seeing a number like this written. 6.022 times 10 to the 23rd. Okay, now this right here is shorthand or calculator notation. If you use Excel, you might also see it there. When you enter a number like this into a calculator, you can't enter the times 10 to the in most calculators. So we put E instead, and that tells the calculator times 10 to the this number, whatever comes next. And in order to enter that on a calculator, we'll talk about that when it comes up. Okay, and that brings us to the last one, which I have to adjust my screen for. So I'm going to walk off for a second and then walk back on after I've made some adjustments. So this is your last chance to get anything copied down that you haven't gotten written yet. All right, so I've got it adjusted, and you may or may not still be able to read this. I don't like how blurry it is, but it is what it is. So, question is, what is a mole? So a mole is something that we have mentioned in this class, but not actually used for anything yet. So, how many of you, I don't know why I'm asking this like this is actually a class. So a mole is no different than a dozen or a score or a gross. Dozen means 12. Baker's dozen, 13. A gross is a dozen or 12 groups of 12, 124. And then a score, for those who don't remember the history class, a score is 20. Okay, it's just another way of reporting numbers to make the numbers we're actually working with easier to manage. So rather than saying, I bought 244 of whatever, usually you're some kind of bulk store if you're buying that much. But instead of buying 288, you can say I bought 2 gross. 2 gross is easier to say. It means you've got 2 sets of 144, or 288. That's a lot easier. Just like it's easier to say I got a dozen eggs than I got 12 eggs, or I got 1.5 dozen eggs if you got 18. So a mole is the same basic idea, but the number is a little larger than a dozen or a score or even a gross. So a mole, 1 mole, is Avogadro's number of particles. So I'm going to move off screen so you can see it, but I'm going to highlight this first. So I'm going to stand over here. So this is how many items you have to have right here. So 602 trillion items. That is how many items you have to have. And that is basically just an Avogadro's number worth of items. So you could have a mole of chairs, or a mole of calculators, or a mole of reams of paper, mole of pencils, mole of erasers. You can have any of those. Not real practical, probably be a pain to store, because a mole of chairs is about the size of a moon. So not going to fit in your garage probably. But you can have, theoretically, a mole of anything. Now, when we're talking about atoms or molecules, it's important that we have decent numbers to work with. And we're talking about so many atoms and molecules whenever we're talking about a material. That's why we have to have an enormous number to represent all of those to make the actual numbers we're working with much, much more manageable. Okay, so a mole is this many, and it's just Avogadro's number. This is Avogadro's number, just written all the way out with all the zeros shown instead of being in scientific notation like it is here and here. And that is pretty much it for this video. Since this is about 10 minutes, I'm going to go ahead and stop there. Again, the worksheet, which this year is called Worksheet 4.1. It's been slightly different every year, but this year it's 4.1. At the top of that worksheet, it has all of this information, and you should be able to find that on Canvas. The next video, we'll be doing 2 practice problems, and then I'll have another one that does 2 more practice problems with the assumption that you have already watched, at that point, the first 2. So that is it for this video. Hopefully the next one in the playlist has the practice problems. So have a wonderful day, and I'll see y'all in like 10, 15 seconds if you're watching the next video.